Hello, chemists. We are going to continue our conversation about solutions. And I wanted to not insult your intelligence, but just to make sure that you're familiar with the fact that dissolving something, right, and melting something are two entirely different things. This is a sodium chloride crystal, and when I put it in water, it dissolves, and we've all seen that happen. And it might look like this. If I were to write it, we would take solid sodium chloride and we would make it sodium chloride AQ and chlorine. So we'd have the sodium ion and the chloride ion in solution, and we call those AQ, right? So it's really interesting how that actually happens, and I wanted to make sure you understood that in the solution process, this idea of dissolving these substances, we know that water is that polar molecule with that negative side and positive side. And when we have the sodium ion in solution, it's sort of sequestered away from the chlorine by water surrounding it, salivating it, making it into solution by the negative side of the water molecule, the oxygen side of the water molecule surrounding the sodium. And the opposite's true for the chlorine. Super interesting that the hydrogen side, the positive side of this polar molecule, separates the sodium from the chlorine. Of course, we can evaporate the water off and get that salt back, but basically that would be the idea of dissolving. If we melt it, and I've heard students use these words interchangeably, when we write the equation for melting, basically we would get molten salt, right? That would make it, that's different. And it doesn't separate like this, it doesn't ionize. And so just making sure that you're clear on the sort of nuance of melting, right? This is melting and this is dissolving. So basically that's a different process. And it's interesting, when we do dissolve it, we have to surround it with water. And the way the water surrounds it is interesting and different. So that leads us to another conversation about that specific and how those ionic compounds would separate in solution. I've got a typo here. I'm going to make sure I cross that off for you. So when we talk about the solute, the substance that's being dissolved in the solution, right, the sodium chloride, if you will, or the sugar, we've talked about that as well. I want to talk about two different types of solutes. There is an electrolyte, and an electrolyte basically is a substance that's put in solution. Electrolytes produce ions in solution, and they conduct electricity, electric conduction. And you've heard probably of lifeguards getting you out of the pool during a lightning storm. Perhaps you've been told to stay away from your bathtub or your shower during a lightning storm. Water, it conducts electricity, but it conducts electricity because of the ions in the solution. Non-electrolytes basically do not, right? It says non-electrolytes, so no electric conduction. And that's because those substances are nonpolar. And so these guys are ionic, and I guess I misspeak. These guys are covalent compounds. Okay, so let's talk about that. So let's talk about electrolyte, okay? And electrolytes can be classified as strong or weak. So a strong electrolyte is something that when you put it in solution, I'll just put strong because we already have electrolyte there. Sodium chloride is an example. It's like the poster child of the strong electrolyte. You put it in solution and it completely ionizes. So I'm just rewriting that equation from above. So this is complete ionization. And it is these charges right here that actually conduct electricity. So let me try to show you that really fast. I'm not that great of an artist, but we're going to try. So essentially we put these the salt in solution, right? And we have our water. And in that solution, we've got our sodium and our chlorine. And if we think about putting, and I can demonstrate this for you guys. We put these two electrodes in water and we hook it up to a light bulb, right? And that light bulb has a thin wire in there and we plug it in. So basically we take this in and we plug it into the wall, which is dangerous. So you shouldn't do this. But basically what we have on this light bulb is we have a positive terminal. I need a different color. We have a positive terminal and we have a negative terminal. And it's the motion of these negative anions that move to the positive terminal and the positive cations that move to the negative terminal that conduct the electricity and they complete the circuit. I'm sure you've all probably been in a situation where you've been given a battery, some wires, and a light bulb and said to turn it on, and you figured out that you had to complete the circuit, right? So this is what happens when I put sodium chloride in solution. We call this a strong electrolyte, okay? And what makes it strong, again, is that complete ionization. There's no salt. There's no NaCl left. It's all been ionized. So that's what I mean by complete ionization. Okay, whoops, where did I go here? Okay, so let's talk about a weak electrolyte. So we do have something called a weak electrolyte. And our favorite weak electrolyte is acetic acid. And that's just vinegar, CH3COOH. So we'll put that into solution and we get CH3COO minus AQ, and H plus AQ, okay? And what's interesting about this reaction is reversible. We've talked about reversible reactions, and so this sets up an equilibrium. And what that means, what's interesting is there's a little bit of this that's not charged, and there's a little bit of this and a little bit of this in that solution. So that's what an equilibrium means, if you recall. There's a little bit of all those there. Sometimes we have more product, more charges, and sometimes we have more reactants. And this is a weak electrolyte. And so when it gets in solution, it looks like this. So basically, we put this this is acetic acid, right? We put it in solution, so it's still in water. And in there it goes. So we have CH3COOH. And in solution, when we're done with this, we have three things. We have the same stuff that we put in. We have the ions, and we have those three things in solution. That's what makes it a weak electrolyte, right? So this is a weak electrolyte. Now, if I were to draw the probes in here again, the sort of the light bulb, right? Basically, I put those electrodes in there, and I have my light bulb going, right? And I plug it in, so I plug it into the wall. And this one, again, we're gonna have the positive move to the negative terminal. We're going to have the negative move to the positive terminal. And again, the electric circuit gets complete, but it's not as strong. And so what happens is the light bulb goes on, but it doesn't go on very brightly. Okay, that's in a weak electrolyte. Strong electrolytes, weak electrolytes. Okay, so the third type of category we can have, okay, are non-electrolytes. And so we'll do that in one more color. Let's do that in blue. So we have non-electrolytes. And non-electrolytes are things like sugar. So C12H22, 22O11, sucrose. We put that in solution, and guess what? No ions. It just gets surrounded by the water, okay? But it doesn't produce any ions. So there are no ions here. So we get partial ionization, we get complete ionization, and we get no ionization. And so this is a non-electrolyte. And what happens here is when we put this in solution, let me see if I can get our look at our beakers here. So when we put these in solution, right, we have that same situation. We have, I don't like that. We were trying to make that black, so let's keep that consistent. So basically, we put these in solution. We draw our beaker and we put our sugar in there. So we have our water. We put sugar in there, so we get C12H22O11. And it's dissolved in there. But when we put the electrodes in there, basically, we could put our electrodes in there. We have our light bulb. We have our wire. We plug it in, right? There are no electrons to move. So no ions equal no electric current, right? And so basically, we call these non-electrolytes because they do not turn the light bulb on. They do not conduct electricity. So non-electrolytes. So when we talk about solutions, we have three flavors, kind of like when we had covalent bonds, we had a polar and a non-polar bond. So when we have electrolytes, we have three different flavors. We have strong electrolytes, weak electrolytes, and non-electrolytes. And really these guys are just subcategories of each other. But basically that's our idea. Okay, so electrolytes. So we will talk in the next lecture about solubility, and we have talked a little bit about that. So in the meantime, review what you remember about solubility. Why does something dissolve in water? Thanks for your attention. Hoping you have a great day.